Good morning students. Today let's discuss about LCM. So in the last class we have studied about HCF. Today we are going to discuss about LCM. And today's our learning objective is to find the LCM of numbers. Let's find the LCM or least common multiple of 3 and 5. Okay, see I have written the multiples of 3 here. 3, 6, 9, 12, 15, 18, etc. etc. Multiples of 3. Table of 3. And I wrote here the multiples of 5. 5's table. 5, 10, 15, 20, 25, etc. In this, can you find any multiple common? Any multiple common here? Yes, 15 is common. 15 is in 3's table and also in 5's table. Anything else we can see? Yes, 30 is also there. See here also in 3's table also 30. In 5's table also 30 is there common. Okay, now my question is, which is the least common multiple LCM, 15 or 30? Which is the smallest one, least common multiple? Absolutely, it is 15. That is LCM, least common multiple. Now let's find the LCM using prime factorization method. Let's find the LCM of numbers by prime factorization. So today we are going to find the LCM of 8 and 12. First of all, we are prime factorizing 8 and 12. See here, 8 divided by 2 is 4, 4 divided by 2 is 2, 2 divided by 2 is 1. So we got the prime factorization of 8, 2 into 2 into 2. We wrote here 8 is equal to 2 into 2 into 2. Now we are going to do with 12. 12 divided by 2, 6. 6 divided by 2, 3. 3 divided by 2 is not possible, so we are taking it with 3 only. 3 divided by 3, 1. So the prime factorization of 12 is 2 into 2 into 3. Look here, 2 into 2 into 3. Now how to find the LCM? We got the prime factorization, okay, fine. Then now we have to find the LCM. How we will find? See the steps here. First, take the common factors in both the lines. So we are taking the common factors in both the lines. Here this 2 is common. Again 2 is there. We can pair that also. This 2. Here also 2 is there. One more 2 is there. Next, take the other numbers which are unpaired. Now we have to look at the other numbers which are unpaired. Which are the numbers here unpaired? Without pair, this 2 and this 3. This 2 and this 3. Now what is the next step? Multiply the selected prime factors together. We should multiply the prime factors together. From the common factor 2 to take this 2. From again the common factor 2 and this 2, take 1 2. Then take what? The unpaired factors. This 2 and this 3. So 2 into 2 into 2 into 2 into 3. That is 24. So let's see the steps once again. First, take the common factors in both the lines. Next, take the other numbers which are unpaired. Multiply the selected prime factors together. The product thus got is the LCM of the given numbers. Let's find the LCM of 24 and 90. So first of all, what we have to do? We have to do the prime factorization of 24 and 90. So I take 24. 24, first we are dividing with 2, the smallest prime number. Then it is divisible, 12 will come. 12 I am dividing with the smallest prime number 2. Then 6 come. 6 I am dividing with 2. 3 comes, and 3 I try to divide with 2, but remainder is coming other than 0. So I can't divide 3 with 2 exactly. So what is the next prime number after 2? 3. I divide 3 with 3. It is possible. I can divide it exactly. So 3 divided by 3 is 1. So what is the prime factorization of 24? 2 into 2 into 2 into 3. See, I wrote here 2 into 2 into 2 into 3. Now I take 90. 90 divided by 2, 45. 45 divided by 3, 15. 15 divided by 3, 5. 5 divided by 5, 1. So what is the prime factorization of 90? 2 into 3 into 3 into 5. 2 into 3 into 3 into 5. Thus LCM is what? LCM is, we will first take the common factors. Here 2 and 2, they are common. That I make it in a circle. And 3 and 3, they are also common. That also I encircled. So this 2 is in a pair and 3 also in a pair. Any other pairs are possible here? No. So how to find the LCM? Take the common factors first. 2. This 2, 2, I take the 2. This 3, 3, I take 1, 3. Then with this, we will multiply all the unpaired factors. So here 2 into 3 into 2 into 2 into 3 into 5. What is the answer? Yes, 360. Find the LCM of 40, 48 and 45. Here also, what is the thing we have to do here? First of all, we have to take the prime factorization. So we are doing the prime factorization of 40, 48 and 45. See, as you can see here, we are prime factorizing 40, 48 and 45. And we got 40 is equal to 2 into 2 into 2 into 5. And 48 is equal to, look here, 48, 2 into 2 into 2 into 2 into 3. Look here, 45, 3 into 3 into 5. So we wrote here, and I am checking. How can we find the LCM of 3 numbers here? We have a doubt, isn't it? So let's see. The first step is, first find the common factors in all the 3 lines. In all the 3 lines, is there any common factors? Look, I can't find any common factor in all the 3 lines. I can't find. Okay, we can't find. Next, take the common factors which are found at least in 2 lines. Now check whether in at least in 2 lines any common factors are there. Yes, it is there. In 40 and 48, prime factorization of 40 and 48, 2 is common. Here also 2 is common. There one more 2 is common. Okay. And anything else? Yes. In prime factorization of 48 and 45, 3 we can take. 3 is common. 3 we can make it a pair. Anything else? Yes. In prime factorization of 40 and 45, 5 is common. We can make it a pair. See, here also 1 5, here also 1 5. Okay, now what we have to do? Third step. Finally, take the factors which are left unmatched. Multiply the selected factors together. The product of the factors is the LCM. So, from the common factors we will take 1. 2, 2. We are taking 1, 2. Here also 2, 2. We are taking 1, 2. Here also 2, 2. We are taking 1, 2. Then 3, 3. We are taking 1, 3. 5, 5. We are taking 1, 5. Then which is unpaired here? This 2 and this 3. This 3 and this 2. That also multiply. What is the final answer? 720. Hope it is clear. LCM by common division method. We are finding the LCM using common division method. It is very easy. Find the LCM of 20, 25 and 30. How to do this? We write the numbers as follows in a row. We will write these numbers together. We are not going to prime factorize it individually. We are doing it together now. We write the numbers as follows in a row. 20, 25, 30. And what is the first step we have to do? Divide the least prime number which divides at least one of the given numbers. So the smallest prime number is 2. So try to divide these numbers with the smallest prime number 2. Is it possible? Yes, 20 is possible. 20 we can divide with 2 exactly. 30 also we can divide by 2 exactly. But 25 it is not possible. 25 is not possible to divide with 2. So leave it. It's okay. At least one of the given numbers have to be divided by 2. Here we have two numbers. 20 and 30 are divisible by 2. So we are continuing doing 2. We wrote 2 here. 20 divided by 2, 10. And 25 divided by 2, it's not possible. So what we will do? Let it be like that. That 25 we will write down. And 30. 30 divided by 2, 15. Again 10, 25, 15. Check. We can, any of the number here, we can divide it by 2 exactly. 25 is not possible. 15 is not possible. But 10 is possible. Yes, so we got one number 10. So again dividing by 2. 10 divided by 2 is 5. But this 25 and 15, they can't. We can't divide 25 and 15 exactly by 2. So let it be like that. Put down 25 and 15 and here 5. Now again check whether any number is there we can divide by 2. Any number is there? 5, 25 and 15. No, we can't divide. But so we will look at the next prime number. After 2, what is the next prime number? 3. Any number is there that we can divide with 3 here? Yes, it is 15. So we are taking 3 now. So 5 we can't divide it by 3. 5, let it be like that. 25 also we will write it down like that. 15 divided by 3, it's 5. Now here look, 5, 25 and 5. Any number is there which is divisible by 2? No. Any number 5, 25, 5 divisible by 3? No. Only 5 is possible. So we take 5 here and 5 divided by 5, 1. 5, 25 and 5 is 5. 5 again divided by 5, 1. We got 1, 5, 1. Now here any number is there which is divisible by 2? No. 3? No. Again 5. So again we wrote 5, 1, write like that. 5 divided by 5, 1. This one also write it like that. So LCM is equal to 2 into 2 into 3 into 5 into 5. 2 into 2 into 3 into 5 into 5. This is LCM by common division method. Once again we will see, divide the least prime number which divides at least one of the given numbers. Here it is 2. The numbers like 25 are not divisible by 2. So they are written as such in the next row. Again divide by 2. Continue this till we have no multiples of 2. Divide by next prime number which is 3 if it is not possible by 2. Then if it is not possible by 2 and 3, then we will take 5. Divide by next prime number 5 if it is not possible by 2 and 3. Again divide by 5. If 5 is not possible, which number we will take? Generally I am asking which number we will take. We will take 7. Yes. So and after we will get here like this, since here it is 2 into 2 into 3 into 5 into 5, the LCM of this question is 2 into 2 into 3 into 5 into 5. Let's see some questions from exercise 3.7. First question is, Renu purchases 2 bags of fertilizers of weight 75 kg and 69 kg. Find the maximum value of weight which can measure the weight of the fertilizer exact number of times. So look at the question here. Renu purchased 2 bags of fertilizers. Weight is 75 kg and 69 kg. We have to find the maximum value of weight which can measure the weight of the fertilizer exact number of times. Okay, look at the word here, maximum. Maximum value of the weight. So here, given weight of 2 bags of fertilizers are 75 kilogram and 69 kilogram. And we want the maximum value of weight. That means highest common factor. HCF we want. Look at the word here, maximum. That means we want the HCF of 2 bags weight. So let's find the HCF then. 75, we are finding the prime factorization. 75 divided by 3, 25. 25 divided by 5, 5. 5 divided by 5, 1. So the prime factorization of 75 are 3 into 5 into 5. Then we are finding the prime factorization of 69. 69 divided by 3, 23. 23, it is possible only with 23. So 23 divided by 23, 1. Now the prime factorization are 75 is equal to 3 into 5 into 5. 69 is equal to 3 into 23. Any common factors are there? Yes, 3 is there. So what is the HCF? 3. Hence 3 kilogram is the maximum value of weight which can measure the weight of the fertilizers exact number of times. Let's see the solution of this question. The first boy steps measure is 63 centimeter. Second boy steps measure is 70 centimeter. And third boy steps measure is 77 centimeter. We are going to find the minimum distance each should cover so that all can cover the distance in complete steps. So that word is minimum. Minimum distance. That means least common multiple, LCM. So we are going to find the LCM using common division method. So we wrote 63, 70, 77. Next we are going to check whether any number is divisible by 2. Yes, 70 is there. 70 is divisible by 2. So we wrote 2 here. We are going to factorize it with 2. Divide it with 2, but 63 is not divisible by 2. 77 is not divisible by 2. Only 70 is possible. So we are dividing 70 with 2 and we got 35. 63 we will write as it is. 77 we will write as it is. Now again we are checking any number is divisible by 2 here. No. With 3 any number? 63 is there. So we are writing 3 here and 63 divided by 3 is 21. 35 we are writing as it is. 77 we are writing as it is. Again we are checking any number is divisible by 2. No. Any number is divisible by 3. Yes. 21 is there. So we are dividing with 21 with 3. 21 divided by 3 is 7. And 35 we will write as it is, and 77 also we will write as it is. And here any number is there again divisible by 2 or 3. No. With 5, yes, 35 is there. 35 is divisible by 5. So we wrote 5 there and we are going to divide 35 with 5, and that is 7. But this 7 we should write as it is, and this 77 also we should write as it is, because they are not divisible by 5 exactly. Now here 7, 7 and 77. Is it possible to divide any of these numbers with 2? No. Any of these numbers with 3? No. With 5? No. Only 7 is possible. So we are dividing it with 7. 7 divided by 7 is 1. 7 divided by 7 is 1. 77 divided by 7 is 11. And now we got 1, 1, 11. Which is possible here? 2? No. 3? No. 5? No. 7? No. What is the next prime number then after 7? 11. Is it possible? Any number is possible to divide with 11? Yes. 11 divided by 11 is possible. So 11 divided by 11, 1. So this one we will write as it is. This one also we will write as it is. Now the LCM is 2 into 3 into 3 into 5 into 7 into 11. That is 6930. Let's see the next question. 3 boys step off together from the same spot. Their steps measures 63 centimeter, 70 centimeter and 77 centimeter respectively. Find the minimum. What is the minimum distance? We have to find the minimum distance. Minimum. Remember that word, minimum. Minimum distance each should cover so that all can cover the distance in complete steps. Let's see the solution of this question. The first boy steps measure is 63 centimeter. Second boy steps measure is 70 centimeter. And third boy steps measure is 77 centimeter. We are going to find the minimum distance each should cover so that all can cover the distance in complete steps. So that word is minimum. Minimum distance. That means least common multiple, LCM. So we are going to find the LCM using common division method. So we wrote 63, 70, 77. Next we are going to check whether any number is divisible by 2. Yes, 70 is there. 70 is divisible by 2. So we wrote 2 here. We are going to factorize it with 2. Divide it with 2, but 63 is not divisible by 2. 77 is not divisible by 2. Only 70 is possible. So we are dividing 70 with 2 and we got 35. 63 we will write as it is. 77 we will write as it is. Now again we are checking any number is divisible by 2 here. No. With 3 any number? 63 is there. So we are writing 3 here and 63 divided by 3 is 21. 35 we are writing as it is. 77 we are writing as it is. Again we are checking any number is divisible by 2. No. Any number is divisible by 3. Yes. 21 is there. So we are dividing with 21 with 3. 21 divided by 3 is 7. And 35 we will write as it is, and 77 also we will write as it is. And here any number is there again divisible by 2 or 3. No. With 5, yes, 35 is there. 35 is divisible by 5. So we wrote 5 there and we are going to divide 35 with 5, and that is 7. But this 7 we should write as it is, and this 77 also we should write as it is, because they are not divisible by 5 exactly. Now here 7, 7 and 77. Is it possible to divide any of these numbers with 2? No. Any of these numbers with 3? No. With 5? No. Only 7 is possible. So we are dividing it with 7. 7 divided by 7 is 1. 7 divided by 7 is 1. 77 divided by 7 is 11. And now we got 1, 1, 11. Which is possible here? 2? No. 3? No. 5? No. 7? No. What is the next prime number then after 7? 11. Is it possible? Any number is possible to divide with 11? Yes. 11 divided by 11 is possible. So 11 divided by 11, 1. So this one we will write as it is. This one also we will write as it is. Now the LCM is 2 into 3 into 3 into 5 into 7 into 11. That is 6930. Next question. The length, breadth and height of a room are 825 centimeter, 675 centimeter and 450 centimeter respectively. Find the longest tape which can measure the 3 dimensions of the room exactly. So given length of the room is 825 centimeter, breadth is 675 centimeter and height is 450 centimeter. And we have to find the longest tape. Longest. So what we will find? They are not asking about the shortest. Longest. That means highest common factor. HCF. So we have to find the HCF of 825, 675 and 450. So we have to factorize it first. 825 we factorize and we got 3 into 5 into 5 into 11. 675 we factorize, not only simply factorize, prime factorize. Then we got 3 into 3 into 3 into 5 into 5. Then we factorize 450. So when we factorize 450, what we got? 450, 2 into 3 into 3 into 5 into 5. And now we write all the factorizations like this. Any common factors we can see? Yes, 3 is there. 3 is common. 5 is common. Another 5 is also common. See here. Look here, 3. Here also 3. Here also 3. Here also 3. So 3 is common. And this 5. 5 is common. Another 5 is also common. So 3 into 5 into 5. That is 75 centimeter. So the longest tape is 75 centimeter. Determine the smallest 3-digit number which is exactly divisible by 6, 8 and 12. So we have to find the smallest 3-digit number. Smallest 3-digit number means we have to find the LCM first. So let's find the LCM of 6, 8 and 12. Not 3, 6, 8 and 12. So we are doing the common division method. 6, 8 and 12. We are dividing it with 2 first. 6 divided by 2 is 3. 8 divided by 2 is 4. 12 divided by 2 is 6. Now we are going to divide it with 2. Because 4 and 6 are there, it is divisible by 2. So again we are dividing it with 2. So 3 we will write as it is. 4 divided by 2 is 2. 6 divided by 2 is 3. Now again we are looking. Any number is possible to divide by 2. Yes, here 2 is there. So 3 we are writing as it is. 2 divided by 2 is 1. 3 divided by 2 is not possible. So we are writing that 3 as it is. Again here 3 are there. So we are dividing it with 3. 1, 1, 1. So what is the LCM? 2 into 2 into 2 into 3. That is 24. Now we need to find the smallest 3-digit multiple of 24. We know that 24 into 4 is 96 and 24 into 5 is 120. So what will be the smallest 3-digit number which is exactly divisible by 6, 8 and 12? That is the multiple of 24. That is 120. Because 24 into 4 is 96. That is a 2-digit number. So what is the 3-digit number starting? 24 into 5. That is 120. Hence 120 is the smallest 3-digit number which is exactly divisible by 6, 8 and 12. Next question. 3 tankers contain 403 liters, 434 liters and 465 liters of diesel respectively. Find the maximum capacity of a container that can measure the diesel of the 3 containers exact number of times. So here we have to find the HCF of 403, 434 and 465 because we have to find the maximum capacity, maximum. So we are finding the HCF, and when we are doing the prime factorization we will get 403 is equal to 13 into 31. 434 is equal to 2 into 7 into 31. 465 is equal to 3 into 5 into 31. Any number is common here? Yeah, 31 is common. That is the HCF. Hence, a container of 31 liters can be measured. The diesel of the 3 containers exact number of times. Okay children, that's all for today. Thank you all of you.